Welcome students, I'm Soumya, Assistant Professor of Department of Mathematics, St. Josephs College of Arts and Science for Women, Hosur. Today I'm going to take differential calculus, unit number 3, partial differentiation. In that, we are going to see about Euler's theorem. Let's see the statement for the Euler's theorem. If f of x, y is homogeneous function of degree n, then x into dou f by dou x plus y into dou f by dou y equal to n into f. This is known as Euler's theorems on homogeneous function. If the function f of x, y is homogeneous function, then we should prove x into dou f by dou x plus y into dou f by dou y equal to nf for this Euler's theorem. Let's see the proof for this statement. Let us assume that f of x, y equal to a naught x power n plus a1 into x power n minus 1 into y plus a2 into x power n minus 2 into y square plus 0 etc. an into y power n. This series will become x power n into f of y by x. Let us differentiate with respect to x and y partially. So first we differentiate partially with x. Dou f by dou x equal to dou by dou x. For this f, we should substitute this function x power n f of y by x. Let partially differentiate n into x power n minus 1 into f of y by x minus x power n f dash of y by x into y by x square. Next, n into x power n minus 1 into f of y by x minus x power n minus 2 into y f dash of y by x. Now partially differentiate with respect to y. Dou f by dou y equal to dou by dou y. For this f function, we should substitute this function x power n f of y by x partially with y. X power n f dash of y by x into y by x. Next, x power n minus 1 into f dash of y by x. Now, let's add the two terms, that is x and y term. So we get x into dou f by dou x plus y into dou f by dou y equal to n into x power n into f of y by x minus x power n minus 1 into y into f dash of y by x plus x power n minus 1 into y into f dash of y by x. So this term will become, let's take the common terms out, that is n and x power n, and this term will become f of y by x. So we already know that x power n into f of y by x we have considered as f. So we substitute in this value here. So we get at last n into f. This is Euler's theorem proof. In general, if f of x1, x2, etc. xm is a homogeneous function of degree n, then x will be x1 into dou f by dou x1 plus x2 into dou f by dou x2 plus etc. plus xm into dou f by dou xm equal to nf. Hence, prove the theorem. Let's see an example for the Euler's theorem. Verify Euler's theorem when u equal to x cube plus y cube plus z cube plus 3xyz. Proof. From the given equations, differentiate partially with respect to x, y and z on both sides. First, they have differentiated with respect to x. We get dou u by dou x equal to 3x square plus 3yz. Next, they differentiated with partial differentiated respect to y. We get dou u by dou y equal to 3y square plus 3zx. Next, they differentiated with respect to z. We get dou u by dou z equal to 3z square plus 3xy. So, we combine these three equations. So, we get x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z. We have written as Euler's theorem format. So, equal to x into 3x square plus 3yz plus y into 3y square plus 3zx plus z into 3z square plus 3xy. In these three terms, we take a common term out. So what we get? 3 into x cube plus y cube plus z cube plus 3 into xyz. So we have in question they have given for this term as u. So we substitute for this term as u. So 3 into u. Hence the solution. Thank you for watching, students.